All right, so section, get my pen here. All right, section 9.1, guys, talks about square roots, okay? And so all we're doing here is we're trying to find each square root. So remember what the square root is. The square root is what number multiplied by itself would give me the number on the inside here, right? So what number when I multiply by itself would give me 16? So I know that 4 times 4 is 16. So the square root of 16 is going to be 4, right? The square root of 64 is 8. Now, when we have fractions, don't get too nervous. Just think about it as a fraction of square roots, okay? So what times what gives me 1? Well, 1. What number multiplied by itself gives me 25? 5, okay? Same thing over here. You can think about this a fraction of square roots, okay? So square root of 1, again, we already said was 1. We just said a little while ago the square root of 64 was 8. All right. So instead of me separating this, I'm going to see if I can just go ahead and do it from here, right? So let's take a look. The square root of 9, 3. The square root of 25 is 5. Okay. The square root of 4 is 2. The square root of 81 is 9. Now, I want you to look at the next two problems here, okay? So the next two problems, we have negatives on both. But if you notice the first one, there's a negative on the outside. You notice the second one, there's a negative on the inside. Okay, so let's do the first one here, the one with the negative on the outside. So forget about the negative for right now. I've asked you, what's the square root of 36? You would say the answer is 6. And if there's a negative on the outside, then we just carry that negative along. Now, there's a difference in this one. Remember what the square root means, right? The square root means what number multiplied by itself would give me a negative 4. Excuse me. Well, I know that 2 times 2 gives me 4. And I also know that negative 2 times negative 2, oops, sorry about that. Let me fix this. And let me get my pen back. Okay, and I also know that negative 2 times negative 2 gives me positive 4. So the only way I could get a negative 4 here was if I did a positive 2 and a negative 2, but it has to be the same exact number, and those would be two different numbers. So if we have a negative on the inside, what we say here, this is not a real number, okay? Let me take a look at the next one here. Okay, so these are telling me very specifically I'm going to use a calculator. And it says approximate to the nearest thousands. So guys, thousands, again, just so we remember, thousands means 3 decimal points, okay? So let me grab my calculator from here. Where is it? Here we go. Oh, man, it's not working right now. Okay, I'll grab one in a little bit, but let's take a look here. I got a calculator. Let me see. Where is it? Right here. Okay, here we go. I'll turn it on. There we go. We got it. Okay, so let's take a look. Square root of 35. Let me clear this out. So on a regular calculator, guys, you should have a square root button. You're going to hit 35, okay? And I'm going to hit enter. And so if you notice the number I'm coming up with 5.916, okay? And I want to go to 3 decimal places. So if I look at the number to the right of the 6, it's a 0. So I'm going to leave that as 5.916. So right here, I'm going to say, this is approximately 5.916. Those little squiggly lines means it's approximate. It's not exactly equal to, because then again, if you notice on my calculator, I have a whole lot of other numbers here as well, right? All right, let's do the square root of 51. Square root of 51. Okay, and let's see. Again, I'm going to go to 3 decimal points. 7.141. So 7.141, okay. The next two have negatives, but remember, all I'm going to do is just make it negative after I do my square root. So square root of 123. Okay, and if I go to 3 decimal places, 11.091, because the number to the right of that 0 is a 5, so it's going to bump up that 0 to a 1. So 11.091 with a negative. Negative 11.091. And finally, one last one, the square root of 214. And I know the answer is negative because there's a negative in front of it. So 14.629. So this is approximately negative 14.629. There we go. Okay. All right, now, just so you can see the answer from the other one. Okay, so let's take a look at this one here. It says, time for an object to fall. It says if we ignore wind resistance, the time in seconds it takes for an object to fall s feet, so s is the number of feet, is given by, and it gives me this equation right here, okay, and that t is for the time. So it says, thus an object will fall 100 feet, and all they're doing is they're plugging in the number 100 right in here, 2.5 seconds. Okay, so our question says, how long would it take an object? So we're looking for the time. Okay, I'm going to write out the equation that gives me 1/4 times the square root of s. Okay, out of a tower, if it's going to fall 2,500 feet. Okay, so let's see if we can do this. 1/4 times the square root. I guess I don't really need that parenthesis there, right? Let me get my eraser. Okay, come back. Oh, come on. Get my pen. Okay, 2,500. All right. So the first thing I'm going to do, I'm going to grab my calculator again. I'm going to take the square root of 2,500. 2,500, there we go. 50. Okay, so I know the square root of 2,500 is 50. Okay, so then we're going to think of this as 1/4 times 50. Guys, if I want to, I can think of that as a fraction as 50 over 1. And if I multiply straight across, 1 times 50 is 50, 4 times 1 is 4, and all I'm going to do now, guys, is just divide it out, okay? So I'm going to take 50 divided by 4, and I'm coming up with 12.5. So that's my time in seconds, so it's going to take 12.5 seconds for that object to fall out of a tower that's 2,500 feet tall. That's a pretty tall tower. Alrighty, that was section 9.1.